Hi everyone, welcome to another tutorial with me, Alex. Today we're going to be talking about your assignment data, and we're going to be working with some of the data that we've given you there for the assignment. Following along with the lecture's topic of visualizing the connections between large data sets as a way of understanding the data, we're going to visualize the way some of these tweets relate to each other. And we'll talk a little bit more about how we can filter out some of that information to find some interesting stories, as well as just some general techniques for working with large data sets. So here I have all of Trump's tweets plotted out as a scattered graph, and this might make a lot of confusion arise because what are my x and y coordinates here? Well, it's a bit arbitrary, but what we've done here is use some artificial intelligence techniques to lay out our data in an interesting manner such that some of the relationships between our data is apparent. So what do I mean by this? Well, up here in the corner, see all of these blue tweets? These are all of the tweets that say thank you. So these are all of the thank you tweets from Trump. And as you might notice, a lot of them are of the format thank you at some person, maybe a little link. So all of those kinds of tweets are up here in the top left corner. And they've all been marked blue. As we head down, nearby them, we have all of the congratulations tweets. And some of the sort of, other tweets that follow this same kind of formula of one big word and then talking to some person or some link. And so you can see these tweets are kind of similar to the thank you tweets, and that's why they're over here near the blue tweets on this graph. Their X and Y location is kind of arbitrary, right? These two little pockets of data could be over on the right-hand side. What matters is that they're near each other, and this pattern continues. So similar tweets are near each other, and different tweets are far apart. This cluster down here, you might be wondering, what are all of these tweets? Well, these are all of the little Twitter links. So all of the shortened Twitter links that Trump tweeted out. And so they're all clustered together down here. All right, so how did we get to this point? That's what we're going to cover for the first half of today's tutorial. And then we're going to look at another perspective of this kind of information in the second half. All right, so how did we get here? Well, let's start by having a look at the assignment data. So here I've got all the assignment data open in VS Code, and you can see there's actually a lot of data files here provided to you. And so these are the files you'll use in your assignment. You can see we have data from Obama, data from Trump, and some combined data about their vocabulary. You might also notice for each file that we have as a CSV, there's also an associated JSON file. So a JSON file is similar to CSV in that it's a way of storing a whole lot of data. But unlike a CSV where things are stored in a sort of table, a sort of grid, in JSON things are stored much more like an object in JavaScript. I don't think I have a good app to visualize it here, so you can see it's all showing it in one line. But the data is kind of similar, but just presented in a different way. If you're more comfortable working with JSONs, totally work with the JSON. It's probably easier. For the sake of the class, because we've been doing CSV, I'm going to do everything today with the CSVs. So if you ignore all of the JSON files, you'll see we have the tweets from Obama and the tweets from Trump. So these are in the presidential, Trump presidential tweets and Obama presidential tweets CSVs. And these contain all of these tweets that you guys can work with. So they have the actual tweet text, they have the date that the tweet was made. For Trump, you have access to the date and the time that they were tweeted. Every single tweet has got a unique ID, so you can identify which tweet you're talking about. And they also have all of the words in the tweet separated into individual tokens. So here we have like I was thrilled. So if we go scroll across, it's probably easier to see if you're in Excel or something. After the tweet, we have I, comma, was, comma, thrilled, etc. So you have all of the individual words as well. And that's got the punctuation and stuff removed for you. So there's quite a lot of data there about each tweet. We also have information about the vocabulary. So this is a useful one. It tells you about all of the different words that have been used. And so each word has also got a unique ID to identify it. And we also have some information about all the words. So how many times is the word used? What percentage of the time was the word used? How many times did Trump use it? How many times did Obama use it? What percentage of the time did Obama use it? What percentage of the time did Trump use it? So a lot of information there. Something that's quite important to note here is that Trump tweeted a lot more than Obama, and so using the frequency is often going to be a bit more useful than looking at just the count. To say that Trump used a word more, you need to make sure that you're sort of being clear whether you're saying about he tweeted that word more because he was tweeting more, or did he actually use the word more frequently in his tweets. So you have that vocab data there as well. The thing that I'm going to talk a little bit now about is this final set of files we have, which are these vector files. And we actually have one for the vocab, we have one for Trump, and we have one for Obama. So these vectors, so a vector is, in this situation, you can think of it as just an array. That's a different word for an array. What we have here is each tweet, so you can see it's matched up by its ID. Each tweet has been converted into a vector. And so what Kaz has done is he's gone through and he's used some fancy algorithms somewhere else. He's done this separately. He's gone through each tweet and converted it into a series of numbers. So you can see here there's actually 300 components to our vector, so it's a sort of an array with 300 elements. And each of them is this number here. I think they all go between -1 and 1. And this combination of 300 numbers is how we are representing our tweets numerically. So it's a bit of a weird conversation to have here, like what are we really talking about? But fundamentally what we're saying is you can take some text, you can convert it into a series of numbers that represents that text. And there's lots of different ways you can do this. So Kaz has used one particular algorithm to convert text into numbers. It's a smart kind of algorithm. And what ends up happening is if you look at all of these numbers and compare them to all the numbers of a different vector, if those numbers are similar to each other, then those tweets are similar to each other. So if you were just ignoring all of these vector components but the first two, you could imagine if we use these as an x and y coordinate and we plotted out all of the vectors, all of the ones that are close to each other would be similar. And so that would be really easy if we had a 2D situation. Unfortunately, we don't. We have a 300D situation. There's 300 components to our vectors. If there were just 3, we could plot them out on a 3D graph. If there were 2, we could plot them on a 2D graph. But because there's, 300 of them, we can't plot out some 300-dimensional graph. That's just, not possible. So what we need to do instead is find some other way of working with these vectors. And the way we're going to do that today is using a couple of different algorithms. Now, these algorithms are kind of tricky. There's not an easy way to do them in JavaScript necessarily. And so what I've gone ahead and done is done some of these algorithms for you and created some new CSVs. So what I've done is using one algorithm called tsne, some people call it tsne, whatever you want to call it. I've taken all 300 elements here in these vectors and I've kind of compressed them down to just 2. So all 300 have been simplified to just 2 as best as we can, such that we get this same pattern here, where all of the similar, close to each other tweets are near each other on the graph. So up here, these are all of the tweets about truth, totally true, so true. All of these tweets are near each other. So we've taken what was a 300-dimensional graph and we've simplified it down to this 2D graph here. Okay. I'll show you this data here. So here's the Obama data. I have each tweet's ID, so you can match it up. And then you've got an X and a Y location to plot that tweet at. So the idea here being all of the tweets that were previously represented as 300-dimensional vectors have now been represented by just a nice, simple 2D representation. So we've got X and Y. And that's what we're plotting here. In fact, we're plotting exactly this data here from Trump. So here are all of my X and Y locations on the graph. Okay. And so this is a type of algorithm. Often they're called manifold learning algorithms, or they can be called dimensionality reduction algorithms. It's all kinds of fancy things. You can see some here. So they've got this example of this multi-dimensional data set. You can see it's a 3D graph, except there's also color. So I guess there's 4 dimensions. So X, Y, Z, and color. Um, and the color helps you identify the data here. But anyway, we've got this 3D graph, and we want to simplify it to a 2D graph. And you can see here there's all kinds of different algorithms, and they all lead to different projections of our 3D graph onto a 2D plane. So it's called a projection. It can be called an embedding, a manifold, all kinds of different things. The algorithm I've chosen to use is TSNE or TSNE. But you can see there's a lot of other algorithms here. And we're not going to cover how they work. Hell, I don't even know how they work. I just know what they do. So they take some higher dimension data and simplify it to a 2D. The other thing I've done is I've got these nice clusters for you. So you can see up here all of these thank you tweets have been colored the same color. And the way I've done this is using a clustering algorithm. So very similar to my manifold algorithm, I've given this algorithm all of these vector data, all of the vector data, and I've used the clustering algorithm to come up with these colors. So it looks at tweets that it thinks are similar and groups them together under one color. And it's done that for a whole lot of different groups. Now, very similar to the TSNE algorithm, here you can see there's a ton of different clustering algorithms. So going across the top here, there's one here called k-means, and that's the one I used. But you can see there's all of these different clustering algorithms. I experimented for a little bit with dbScan to see if I could get a better result for you guys. But in the end, I just went with k-means, which is a very simple clustering algorithm. You can see here on this website, scikit-learn, they've got some examples of different data sets, and you can see the different results when you run this clustering algorithm. So on the left here, you can see all these different types of data, and you can see that k-means does an okay job at some of them, and it does a pretty bad job at others. So you can see here, for example, this one here, we've got these 2 donut rings. You can see k-means has not figured out the 2 clusters. It's sort of just cut it down the middle. Whereas something like dbScan has figured out there's sort of 2 clusters here, they're separate. Whereas k-means has done pretty well down here on this simple kind of design where there's 3 separate clusters of equal kind of size. So each of these different clustering algorithms, and same with each of these manifold algorithms, they're all different and they all have different strengths and weaknesses. So depending on the situation, you might want to use different algorithms. What I would recommend doing is just experimenting with all of them. Just play around with them to see what works best for your data science, your data set. This kind of data science is a very imprecise science. There's nothing really technical here. There's nothing like mathematical that you can point to and say, hey, these objects belong to this particular data set. These are all climate tweets. It's very imprecise. You might end up with clusters that make no sense. And in fact, most of these clusters here don't really make much sense. In the middle, it sort of just turns into one big blob, and it can't really differentiate between all of these tweets. Some of the ones up here, these are all the @Fox News tweets. They're all a very similar format. They've got a time in them. They've got an @Fox News. But a lot of these tweets in here just get lost in one big cluster. So I've used k-means. K-means is an interesting algorithm because you actually need to say how many clusters you want. Some of these algorithms figure out, hey, it looks like there's 3 clusters down here. But with k-means, you've got to explicitly say, find me 3 clusters. And so in this situation here, I've said, find me 8 clusters. I don't think there really are 8. And so this is one of the weaknesses of this algorithm. It's imprecise, it's prone to human error, and it needs a lot of tweaking for it to work. Looking here in this table, it also says, k-means not very good when there's too many clusters. It doesn't do too well if, it says you need even cluster size. So if you have one cluster that's really big, like this big thing in the middle, k-means is going to split it up into lots of clusters. So maybe k-means isn't the best one for my data set here. Maybe we need something that's better for uneven cluster size, like mean shift. Maybe mean shift would be better. I don't know. Now, doing this data, these calculations, I've done it for you and put all the data in a CSV. I'm going to make a separate video that just runs down how I actually did this. You can do it in a few different ways. I've got an example using a web interface. One example where I did it in JavaScript, but it's not really something you would do in JavaScript. And the way I actually did it, which is using Python. So I'll do a little video on that separate to this one, a little extension if you want to cover that. So if you've learnt Python, or Python's pretty readable, so if you're just curious as to how I did it, or you want to do it yourself, check out that video, and there you'll be able to tweak some of these settings and play around with it yourself. So if you want to try out different clustering algorithms or change how many clusters the k-means algorithm is searching for, then go and have a look at that video. So for today's purposes, I've done the data science for you. I've exported the x and y from the t-SNE algorithm. And you can see on the left here, these are the clusters. So they're labeled 0 through 7. So these are the 8 clusters. And so it's just, it's just a number. Which cluster does this tweet belong to? So that's all the data stuff we've got going on here. This is what you're going to have for the assignment, and you'll have access to these exports that I've done here myself. I would really heavily recommend you go and have a look at that other video to see how to do this yourself. One of the really interesting things about t-SNE is every single time you run it, you actually get different results. And so this is just one result here that I've just run it through one time. So if you want your own unique cluster and your own unique layout like this, then go ahead and run the t-SNE algorithm yourself. Okay, so now that we know what data we're going to work with, let's have a look at making this visualization here. Okay. So to make this visualization, let's jump into the code. The first thing I've done here is load in the presidential tweets from Trump and the t-SNE data that I made for you. In modern D3 and modern JavaScript, there's actually some nicer ways to load in multiple files. But for us purposes, we're just loading in a couple of files. This is totally fine. So we're saying load in the Trump tweets. And once you're done, pass those tweets into a function. And that function is going to load all of the t-SNE data. And once that's done, it's going to take the t-SNE data and pass that into a function. And that function is going to call makePlot. And so at this point in here, both the tweet data and the t-SNE data is loaded, and so we can make our plot. If you're interested, have a look at the modern D3 way of loading in multiple files. If you have to load in, 1,000 files, this is obviously not going to work very well. So makePlot is going to take in the tweet data and the t-SNE data. So let's have a look at that function. So here's makePlot. Very similar to a lot of our other plots in the past. We're making a simple scatter plot here. The hard work was, making those t-SNE projections, so this is really the easy side of things. So just sort of expanding stuff we've done before. We're getting our x and y location from the t-SNE data. You can make your own unpack function or use one if you prefer. Otherwise, just use map. So this version of map, I know there was some confusion regarding the P5 version of map. This version of map is the one that belongs to an array. And what we're doing here is we're saying, I want to return an array. So the map function returns an array based on my current array. And what it does is it goes through every element in your array and returns based on this function here. So what I'm doing is I'm saying, give me every element in my t-SNE data. So every element, I'm calling it D for datum. You can call it whatever you want. And for each of those elements, I just want to get the x coordinate. So I'm returning the x coordinate. And so what this is going to do is it's going to give me an array with all of the x coordinates from the t-SNE data. So we're mapping out of it all of the x coordinates. You can use unpack if you prefer. It's totally up to you. I like map because it gives me a bit of control. If I needed to convert this, maybe I needed to do some parsing, I could do that in here, nice and easy. So same thing for the y data, getting it out of the t-SNE data. And then I'm also doing a little hover tooltip here. So we've already covered this in a previous week. In this case, I'm mapping out all of the tweet text. So I'm getting the text from my tweet data, and then we're plotting it. The final thing that we want to do here to make this look like our visualization is we want to take our cluster data. So this is those numbers 0, 1, 2, 3, 4, 5, 6, 7 for our 8 clusters, and I'm using that for my color. So the way color works here is we give it a number for our color, and it's going to automatically spread those colors out across some color scale. So there's a default built-in color scale, but I've decided to change mine to Jet. The reason I've done this is that the built-in color scale is normally designed for continuous data. So it's, it goes from like a dark red to a light red, or some data that goes from green to red, something like that. Jet, if we have a look here in the reference for the color scales, if I go down to the Jet color scale, you can see it's very bright. It's a full rainbow. And so this is good because it means each of my clusters is going to have its own unique color. So these are all the different color scales you can experiment with. You can also define your own color scales here using RGB codes, and actually we're going to do that in the second part of today's tutorial. So we'll come back to that. And so what I've done here is I've just said use this Jet color scale and use my cluster labels for the color. And so this means that each cluster is colored based on the cluster. Simple enough. The final thing to do here is just a little bit of layout stuff. When you hover over a graph like this, by default it has this compare data on hover, which is sort of designed for going across the x-coordinate. It's not very useful when you want to mouse over big complicated data like this. So instead, I would normally turn on show closest data on hover. But I'd like that to be on by default, so that my user doesn't have to do that. I just want it to show whichever one you're mousing over. And so I've just changed the layout here, set the hover mode to closest. tsne gives you results on an x and y axis that doesn't really make any sense. Like we were saying earlier, these clusters over here could be, they could be on the right, they could be in the bottom. The x and y location doesn't really matter, doesn't mean anything. And so I've turned off the axes here, because it can bring some confusion. This has got a value of like negative 57x, but that doesn't mean anything. It doesn't give you any information about the tweet. So I've turned off the axes using this syntax here. So I've just set visible to false for both axes. And then we plot out to the screen. So what I'd like you guys to do for a little activity here is to just get yourself comfortable with this code. What I'd like you to do is visualize the Obama tweets. So I've got the exact same stuff for Obama, and also visualize the vocabulary. So we've actually got the same kind of stuff, same clustering for words. So words that are similar to each other will be in similar clusters. So have a go at loading in the Obama data and the vocab data. I found there weren't many meaningful clusters in the Obama data, but maybe I just didn't look hard enough. I found some pretty clear things in the Trump data, like these thank you ones. The vocab data has got some pretty clear clusters too, so have a look if you can see some of them. One I noticed was a cluster full of names, so all these first names got clustered together. So see if you can find that cluster. I found a couple of places where all of the numbers, or all of the all of the year style numbers were combined into one cluster. So have a look at those data sets, so visualizing those. And then I'd also like you just to experiment a little bit with changing some of this styling here. So putting a title in it. You could experiment with some of the different color scales to see what kind of results you can get there. If you would like to go ahead and make your own custom color scale, you can do that. And even visualizing different things with color. So maybe you could look at the sentiment that we have for each tweet, or other things like that. Alright, so we're going to do that for a little while now, just to get comfortable with the data. And then we're going to come back and do a little bit more work with this large data set. So take 15-20 minutes to get comfortable with this code. And explore the data sets a little bit, see if you can find some interesting clusters, see if you can find some clusters that don't make any sense, experiment with all of that kind of stuff. And then we're going to come back and we'll talk a bit more, okay? Alright, so let's talk about the data set a little bit more. So because we had such a large data set with so many values and so many variables to visualize, something that we might want to do is filter out a lot of that extra data so we can focus on a particular topic. In this visualization, I've filtered out the text of the tweets so that only tweets that mention a few topics to do with climate change will be included. So you could say these are all of the Obama and Trump tweets to do with the climate, or at least a rough approximation of that. So what I've also done here is I've colored the tweets. So blue are Obama tweets, and red are Trump tweets. The layout here is still the tsne data. So all of these are still located close to similar tweets. So you can see here, these are all of the climate change tweets from Obama. These ones here seem to be about Pennsylvania from Trump, a little bit on fracking. And so you might find some similar things near each other as well. I find it's generally a little bit better with Trump, actually, because his tweets are often a bit shorter and, so shall we say, simpler. Whereas Obama tweets often have a lot of words in them. They're often quite complex. He talks about himself in the third person a lot, which can make it, can skew the data a little bit. So, you might think maybe this could be better visualized on a timeline. So we can see, when were they tweeting, all kinds of things like that. So anyway, this is just one way of doing it. So let's have a look at the code. This is a bit of a more complicated program. So what I've done is I've split it into functions. So if you remember back to like design programming, we talked a lot about how you can use functions to simplify your code. I've tried to do that as best I can here. So, like I mentioned earlier, there are modern versions of D3, and modern JavaScript has better ways of loading in multiple files. I could give it an array with all of these different file names. But for today's purposes, we're going to do the quick and dirty way, which is just to put these functions one after another, and everything will be loaded on the inside. So what I've done here is, in this situation, I've combined the Trump tweets, the Obama tweets, and their tsne data all into one big tweets array here, tweets. And so that's what this combine and filter function does. And then once I've got all of that tweet data in one big array, I'm doing a make plot function here. So 2 steps, I'm combining and filtering my data, and then I'm making a plot. Something I'd like to highlight is that there's lots of ways of doing all of this, and you might decide that instead you'd like to do your combination and your filtering beforehand. So instead of doing it every single time someone opens your website, you might want to do it beforehand and save it as a CSV. You could definitely do this in Google Sheets or Excel. It could even be easier if you're more comfortable in those platforms. They have ways of combining data. They have ways of filtering. I'm just doing it in code because it gives us a bit more flexibility. We can do things on the fly. But if you see this tutorial and you go, hey, that was beyond me, I'd rather just do this in Excel for my assignment, that's totally fine. Do whatever's going to be easiest for you. So let's have a look at the combine and filter function. So let's just remember its purpose is going to be combine all of the data together into one big array, and then filter it out so that only tweets that mention topics to do with climate change are included. So let's have a look. The first thing I'm going to do is copy all of my tsne data into my tweet data. I'm doing this with a modern JavaScript map function using object.assign. You can look all of this up in the JavaScript reference, but this is a simple way of copying all of my X, Y, and cluster IDs from the CSV data there into my actual tweet data. So now my Obama tweets and my Trump tweets have the tweet ID, it has the tweet text, it has the sentiment of the tweet, so if it's positive or negative, they're happy or sad kind of thing. It has all of the tokens, and it also has an X and a Y and a cluster ID. Now, if you're more comfortable with sort of old school JavaScript, you can totally write this exact same code in a sort of more explicit way. So I'll just demonstrate that here. If you prefer for loops and the sort of for let I technique, you could rewrite this code here, lines 3 and 4, with a for loop like this. So I'm going to loop through all of the Trump tweets .length I++. So you might this might be a more comfortable way of doing it. And what I'm doing here is I want to say Trump tweets index I, and I want to create a .x value and set it to the tsne data, data trumps x as well. So what I'm doing is I'm copying my x value into my tweet value. And so I'm doing the same thing for the y. I'm doing the same thing for the cluster, .cluster ID, and cluster ID. So this is all I'm doing in this same line up here. But instead of splitting it out into 5 lines, I'm doing it on 1 line. If you prefer this kind of syntax here, it's totally fine. Whatever you prefer. I would definitely recommend, if you're going to continue JavaScript programming, and you guys have been programming in JavaScript for 3 years now, so you probably want to keep up with how things are going with JavaScript. This is definitely the more modern way of programming it. This kind of syntax. So I would definitely have a go at learning this kind of syntax. There's YouTube videos that'll teach you all of this kind of stuff, and of course the JavaScript reference. But if you're more comfortable in this kind of old school style, then go for it. Whatever works. The next thing I'm doing is I'm going through and I'm adding a new author parameter. So again, you could do this in this old kind of technique here. You could do it all at the same go. So you could say Trump tweets I.author is equal to Trump. I'm doing it in this technique down here, the for let of format, where I'm simply looping through every element in my array and setting the author to Trump and the author to Obama. But if you prefer this way, go ahead. Again, bit more modern JavaScript syntax. What I want to do now is combine the Obama and Trump tweets into one big array. There's lots of different ways you can do this. I'm doing this new spread syntax. This is a slightly more modern way of doing this, and it's a little bit quicker. And I also follow the Airbnb JavaScript style guide, and this is sort of the way they're leaning. So this is the way I'm doing it, but however you'd like to do it is totally fine. But essentially what I'm doing here is I'm just sticking the Obama tweets on at the end of all of the Trump tweets, something that you could very easily do in Excel or Google Sheets. So at this point, I have all my tweets together. I have all of my tsne data included. I've set up an author parameter. And so I've got all my tweets in one place. What I'd like to now do is filter out the tweets to only include the ones that mention some of these topics. And so you can see here I'm using the filter method here from arrays, which is a method which will take each element in my array and pass it into this function. And so the function I've made here is just checking whether that tweet includes one of these topics. So if you tweet, solar energy is the future, then energy is going to be included in that text. And so it's going to pass this filter. It's going to be true. So all of the tweets which mention one of these three words here is going to be included. The filter function is really simple, and we can have a look at a simple version down here. Let's have a look at this one. So this is saying, look at all of my tweets and only include the tweets which have a sentiment less than 0. So sentiment is another little bit of AI stuff that Kaz has done for you. Each tweet has a sentiment value I think it's between -1 and 1, and this just says how positive and negative your tweet is. So if you use lots of happy words like happy and joyful and positive future, then you'll get a high sentiment value, and if you use angry words, sad words, you'll get a negative amount. These are just a couple of other filters that you can experiment with. Have a look at them. So if you want to get all the tweets that include the word thank, all the tweets that have a positive sort of outlook, you can have a look at that. I've also included some stuff to do with dates. So if you're interested in how to work with the date time format, have a look at that in the reference and play around with these filters. But that's sort of the first function here, combine and filter. So just in summary, what we've done is we have copied the tsne data into the tweet data, we've added an author property, and then we've combined all of that data together into one big tweet array. I've then filtered that tweets array to only include tweets that mention climate, energy, or green. Of course, you can add more things in here, so if you want to add solar, whatever. And there's some other filters here as well you can experiment with, and that's what we're actually going to get you to do shortly. Is experiment with some of these filters. See, combining filters, for example. So you could say, I want all of the climate tweets that came out before 2014, and that's what this would do. So we'd first filter out all of those ones, and then we'd filter all of the dates. Alright, so that's our function, and once it's all done, it returns the tweets to us for us to use. And so now we can collapse this function and not worry about it. So coming back down the bottom here, you can see we've called combine and filter, we've passed in all of the data, and now we have our tweets. And we can use those tweets to make a plot. So let's have a look at the make plot function. So very similar to the previous example, here we are making a plot using all of the tweet data, but of course it's filtered, so we're not going to get like, a million tweets. And very similar to the previous example, I'm mapping out the different variables I need. You could use an unpack function if you prefer. So you can see here I'm getting the X and Y data of my tweets. So instead of getting it from tcd data and getting like the text from the tweet data, it's all in tweets now. So everything comes from tweets. So I'm using the X and Y for my tcd projection. For the tooltip, this is a little bit complicated, but what I've done is I've got author colon text. So if we look here in my visualization, it says Trump, my visit to Japan. Here it says Obama, today, etc. So this is just putting that little bit of text there that says Trump, that says Obama, and the colon and the spacebar. And then we have the actual tweet text. Now, I don't know a good way to get all of the text on into a nice box like this. I'm sure some of you guys who are, whizzes at SVG and CSS have figured out some styling to do this. But if you notice in the previous example, I can just go back to it here. When we were visualizing these clusters, the text was all in one big line. And you can see most of it gets cut off for the longer tweets. And so you can't read the full tooltip. I'm sure there's a good way of doing this. I don't know what it is. I played around with it for a little bit, but I'm not very good at SVG and CSS. So I'm sure there's a way to do it. But what I ended up doing is just going onto Stack Overflow and finding someone who'd made a function that kind of does this for me. So you can see here I've referenced it, just this Stack Overflow answer. And it's just this function here which will take in a big string and it splits it out with some breaks here. So the little new line breaks. And so this creates a nice little pattern, nice little function for us here, such that our tweets will actually fit. So I'm just inserting new lines every now and then. It takes in a max line length. So if there's more than 64 characters, it creates a new line. You don't have to worry about how this works. In fact, I got halfway through understanding how it works, and I sort of just said, you know what, it doesn't matter. I've copied it from Stack Overflow. I've put a little reference in there. I modified it slightly to work for our example, and now we don't need to worry about it. So if you're wondering, I'm just putting that in here so that our text actually goes in a nice box rather than going in a big straight line. This is not the way you should do this kind of thing. Ideally, you would make this kind of stylistic change using style techniques, so CSS or modifying some kind of style parameter. I couldn't figure it out, so I just put some new lines in my text. So, it's not the best way, but I needed something that works, and this works. So the rest of the code is very similar to our previous example. Instead of using the tweet cluster for the color, I've used the author. So little ternary operator here, just a little mini if statement. If the author is Trump, return 0. If the author is not Trump, so it's Obama, return a 1. And for the color scale, instead of using Jet or some other color scale, I've created my own here. And so in this color scale, the value of 0 is given red, and the value of 1 is given blue. So this is how you can make your own custom color scale. You could have a look in the reference as well, more on how to do this. And the rest of the code is the same. So exactly the same as the previous example. And so then we can plot out our plot. So we've got a simple program here split into multiple functions. If this is all in one function, it would be quite complex, but spreading it apart like this makes it nice and simple. We combine and filter our data, and then we make a plot. Again, the whole combine and filter step could be done in Excel or Sheets, but I've decided to do it in code. And then the making of the plot is very, very similar to the previous example. So what we'd like you to do here is, again, experiment with some of the other data sets as well. So, bringing in the vocab data could be interesting. The main thing I'd love you to explore is this filter function. So getting comfortable with filtering out your data. This is really important with a big data set because there's so much information. And so we need to really filter it down to tell a story. So have a go at some of these filters. Make your own filter, combine filters, see if you can find a story. I was experimenting with one. This is an interesting little experiment here. If you look up how dates work, you'll find out this is sort of the 4th of July. So this is all of the tweets on the 4th of July, 2015. There's not actually very many, so maybe you can find a smarter way of doing this. Um, so yeah, experimenting with the filters, experimenting with the colors, all that kind of stuff. Again, I mean, this is all quite basic plotting stuff. We're dealing with simple scatter plots with simple colors. A lot of the challenge here has actually been in the making of the data set and getting our heads around it. So that's it from me. Jump into exploring these filters. If you want more information about how we actually came up with these data sets, then there's an extension video. Again, I'm going to cover how to do it in JavaScript, how to do it in Python, and how to do it with a web interface. So have a look at that. If you're new to Python, you'll be totally fine anyway, just to have a look. Yeah, I'll see you guys in the future.